we have a problem in trigonometry. Okay, let's go to the question. Find the principal solutions in radians of the equation 4 sin square theta negative 3 equals to 0. Actually, in this equation, the Greek theta over here represents a variable. So that is we have to find the value of this theta. Actually, this theta represents an angle measure over here. Whenever I want to find the principal solutions for a trigonometric equation, so I have to get the angle measure within the interval 0, 2 pi in radians. So that's called principal solutions. Here in this interval, we use square bracket on the left side over here and parenthesis on the right side over here. That means it's closed on the left side, open on the right side. Closed means we can include 0, but we cannot include 2 pi. We have to get the angle measure theta, which is less than 2 pi. That is, we can write this one as 0 less than or equal to theta less than 2 pi. So here 0 is included, but 2 pi is not included. I consider the angle measure over here in radians because the question says that we have to find the principal solutions in radians. In case I want to get the principal solutions in degrees, I may have to consider the interval 0 degree, 360 degrees. Okay, now we can start solving the given trigonometric equation. That is 4 sin square theta negative 3. Let me write the equation as it is. That is 4 sin square theta negative 3 equals to 0. Okay, now to solve for theta, I have to get rid of the values around the trigonometric function sine. So for that, let me add 3 to both sides to get rid of the negative 3 over here. When I add 3 to both sides, the negative 3 positive 3 will cancel out. I'm getting 4 sin square theta equals to 3. Now let me divide both sides by 4. Then this 4 will cancel out. I'm getting sin square theta equals to 3 over 4. Okay, now I'm going to write the sin square theta as sin theta the whole square equals to 3/4. Now to get rid of the square over here, I'm taking square root on both sides. Okay, whenever I take a square root on both sides of an equation, for one of the square roots, I have to consider positive or negative sign. Usually we consider positive or negative sign for the square root which contains number inside. This square root contains number inside 3/4. So we can consider positive or negative sign for the square root on the right side. On the left side, the square root and square will cancel out. Then I'm getting sin theta equals to positive or negative. And here we have square root for the fraction 3/4. Whenever we have square root for a fraction, what we can do is we can distribute the square root for numerator and denominator. Then I'm getting square root of 3 over square root of 4. Then I'm getting sin theta equals to positive or negative square root of 3 over the evaluation of square root of 4 is 2. I got two values for sin theta. One is sin theta equals to positive square root of 3 over 2, and the other one is sin theta equals to negative square root of 3 over 2. That is, we can split up this one into two solutions. One time we can write this square root of 3 over 2 for positive sign and other time for negative sign. Okay, now we have two equations. One is sin theta equals to square root of 3 over 2 and other one is sin theta equals to negative square root of 3 over 2. Let's solve these two equations one by one. First, let me solve the first equation, that is sin theta equals to square root of 3 over 2. So here the value of sin theta is square root of 3 over 2. Okay, to solve for theta in this equation, let me consider the four quadrants over here. So here in this four quadrants, here we have 0 radians, here we have pi over 2 radians, here we have pi radians, here we have 3 pi over 2 radians, and here we have 2 pi. Actually 2 pi is at the same position of 0. Since we have 2 pi is at the same position of 0, usually we ignore 2 pi. That's why in the beginning when I started explaining about principal solutions, I said the interval 0, 2 pi, and I said we have the open interval over here because 2 pi is not included. The reason is both 0 and 2 pi are at the same position, so we just consider only 0 and we don't include 2 pi. Okay, so here this is the first quadrant and this is the second quadrant and this is the third quadrant and this is the fourth quadrant. And now we can consider the ASTC concept. That is, ASTC means A in the first quadrant, S in the second quadrant, T in the third quadrant and C in the fourth quadrant. You can remember this ASTC as all silver teacups or all students take calculus. So here we have A in the first quadrant. That means all trigonometric ratios are positive in the first quadrant. Sine, cosine, tangent, cosecant, secant, cotangent, all of them are positive in the first quadrant. In the second quadrant, we have the letter S. S means sine and its reciprocal cosecant are positive. The rest are negative in the second one. In the third one, T means tangent and its reciprocal cotangent are positive, the rest are negative. The fourth quadrant we have C means cosine and its reciprocal secant are positive, the rest are negative. Okay, so here sin theta is positive means like the angle measure should be in the first quadrant or in the second quadrant, because in these two quadrants sin theta is positive, because here we have a positive value. So since we have a positive value, we have to consider the angle measure theta in the first quadrant and second quadrants. In these two quadrants, sin is positive. Okay, first we have to get the value in the first quadrant. So how do we have to get the angle measure theta in the first quadrant? For that, we can use either unit circle or trigonometric ratio table. So where we can get the angle measure for which the value of sine is square root of 3 over 2. So in the first quadrant, when the sine, the trigonometric ratio is equal to square root of 3 over 2, the angle measure must be 60 degree. That means pi over 3 radians. So this is the angle measure we are getting in the first quadrant over here. Let me write it. Pi over 3 is the angle measure I'm getting in the first quadrant, for which, when I plug in this pi over 3 for this theta over here, the value of sine is square root of 3 over 2. And also we have to get one more angle in the second quadrant, because in the second quadrant also the sine is positive. So here we have a positive value. For that, what I have to do is I have to use this angle measure pi over 3 that I got in the first quadrant. I have to use this angle measure as a reference angle over here. So when I use this pi over 3 as a reference angle over here, now to get the angle measure over here in the second quadrant, we have to subtract this reference angle pi over 3 from this pi. Then we get pi negative pi over 3. When I simplify this one, I am getting 2 pi over 3. So this is the angle measure in the second quadrant for theta, for which the value of sine is square root of 3 over 2. So now I got two values of theta for this equation. Sin theta is equal to square root of 3 over 2. One is in the first quadrant, that is pi over 3, and the second value of theta is 2 pi over 3, that is in the second quadrant. Okay, now we have to make sure both these values of theta must be in the interval 0, 2 pi. Then only we can consider the values we got for theta as principal solutions. Okay, now we have finished solving the first equation, that is sin theta equals to square root of 3 over 2, and we got two values for theta, pi over 3 and 2 pi over 3. Both of them are in radians and both of them are in this interval. Okay, now let's solving the second equation, that is sin theta equals to negative square root of 3 over 2. Okay, let me continue this on the next page. So let me write the equation, that is sin theta equals to negative square root of 3 over 2. Here we have a negative value. Okay, whenever I want to solve this kind of trigonometric equations with a negative value on the right side, initially I have to assume this one as a positive value, that is let sin theta equals to positive square root of 3 over 2. Okay, I have assumed this one as a positive value. Now I have to get the angle measure theta in the first quadrant. Already we have solved this equation on the previous page, and we got the angle measure theta in the first quadrant, which is pi over 3. Okay, now we have to identify the quadrant where sin theta is negative. In those quadrants, we have to consider this angle measure as a reference angle, and we have to find the angle measure theta in those quadrants for which the value of this sine is negative square root of 3 over 2. For that, let me draw the four quadrants over here. Okay, so here, as I said already, 0, pi over 2, here pi, and here we have 3 pi over 2, and already we know that this is first quadrant, second quadrant, and this is third quadrant, and this is fourth quadrant. So here all trigonometric ratios are positive, yes, and T and C. Okay, now we have to consider the quadrant where the sign is negative. Already we know that the sign is positive in the first quadrant and the second quadrant. So in the third quadrant, a tangent and its reciprocal cotangent are positive. The rest are negative. The rest are negative means the sign also is negative in the third quadrant. In the fourth quadrant, cosine and its reciprocal secant are positive. The rest are negative. Rest means the sign is also negative. So sign is negative in two quadrants, the third quadrant and fourth quadrant. In these two quadrants, I have to use this angle measure pi over 3 as reference angle and get the angle measures in these two quadrants for which the value of sine is negative square root of 3 over 2. So now let me draw the terminal side over here. Now I have to consider this pi over 3 as a reference angle in the third quadrant. So now to get the angle measure over here, I need to add this pi over 3 to this pi. Then I'm getting pi positive pi over 3. When I simplify, I'm getting 4 pi over 3. So this is the angle measure we get in the third quadrant for which the value of this sine is a negative square root of 3 over 2. So now I got the value of theta for which the value of sine is negative square root of 3 over 2 in third quadrant. That is 4 pi over 3. Okay, now we have to get one more angle in the fourth quadrant, because in the fourth quadrant also the sign is negative. In the fourth quadrant, so again we have to take this pi over 3 as a reference angle. And here we can consider 2 pi, because we are about to complete one full rotation. So when we are reaching this position, we have to consider 2 pi. We should not consider 0, because we started from 0 and we are rotating. We are about to complete one rotation. Then we have to consider 2 pi. Now to get the angle measure in the fourth quadrant over here, now we have to subtract this reference angle pi over 3 from this 2 pi. Then I'm getting 2 pi negative pi over 3. So when I simplify this one, I'm getting 5 pi over 3. So this is the angle measure I'm getting in the fourth quadrant, for which the value of sine is negative square root of 3 over 2. And also we have to make sure both these values are in the interval 0 comma 2 pi, so that we can consider these two values of theta as principal solutions. Okay, now let me list out all the values of theta. So already we got it, pi over 3, 2 pi over 3 here, pi over 3, 2 pi over 3, and now we got two more values for theta, that is 4 pi over 3 comma 5 pi over 3. So solving the given trigonometric equation, I am getting 4 values for theta, and we have all the 4 values here in the interval 0 comma 2 pi. So these are the principal solutions for the given trigonometric equation.